So welcome back friends. So let's continue with our discussion of non-exact differential equation. So we have already discussed three types. So the first type, then second type and the third type. So in today's lesson we will discuss the fourth type of non-exact differential equation. So we saw that whenever we will multiply a non-exact differential equation by an integrating factor, we will get a exact differential equation, and we can apply the formula that we have derived for the exact differential equations. So let's see. So in type 4, this is the general form of the type 4 of non-exact differential equation, which you will understand this much better with the illustration. So just see this general form once: x to the power a, y to the power b, then multiplied by my dx plus nx dy. Then the second term is similar to the first term, where x to the power of a dash, y to the power of b dash, then m dash y dx plus nx n dash x dy is equal to 0. So here your integrating factor will be x to the power of h and y to the power of k. So if you want to find the h and k, then we have given two equations that you have to solve for h and k. So if you see here, a plus h plus 1 divided by m is equal to b plus k plus 1 divided by n. So here a and m values you will find by comparing the this general form with our equation that we have to solve. So we will see how we will apply this. So don't stress yourself too much and just sit back and watch this video. So let's start with this illustration. So with this illustration you will understand this better. So first we will try to bring our problem in our general form. So our general form is x to the power of a, y to the power of b, then m y dx plus n x dy. Then the second term is x a dash y b dash, then m dash y dx plus n dash x dy equal to 0. So let's first bring this in this form. So let's first split this. So x y square dx plus 2x square y cube dx. We have multiplied dx with both the terms. Then x square y dy minus x cube y square dy is equal to 0. So now what we will do? We will club the terms, because we want one dx term and one dy term. So we will have one dx term and let's club it with this dy term. Similarly, we will club these two terms. So when you club this, you get xy squared dx plus x squared y dy. This is our first term. Similarly, bringing these two terms together, 2x squared y cube dx minus x cube y square dy equal to 0. So let's bring our the common out. So here xy is common, xy y dx plus x dy plus, here you can bring out x square y square as common, x square into y square common. So inside you will get 2y dx minus x dy is equal to 0. So now we will just compare this. So here you can see x to the power of 1, y to the power of 1. So a value is 1, b value is 1, then m is also 1. So you can write m is equal to 1. So actually we are comparing it. Then n, if you see, if you compare it, you are having n is also 1. Now let's compare a dash. So a dash you have 2, a dash is 2, b dash is also 2, then m dash is 2, and if you see n dash is minus 1. So now let's solve for, so we know that our integrating factor is x to the power h and y to the power k, where h and k we have to solve by the equation that I have said you. So this equation we have to solve. So I will write the equation first. So a plus h plus 1 divided by m is equal to b plus k plus 1 divided by n. So this is our first equation. We will solve it. So let's solve it. Substitute the value of a is equal to 1. Then write for m, you can write again substitute as 1. Again for b substitute 1. Again for n substitute 1. So you can see that here you got h plus 2 is equal to k plus 2. So here 2 and 2 will get cancelled. So h is equal to k. So this is your first relation. So our second equation was a dash h plus 1 divided by m dash b dash k plus 1 divided by n dash. So our a dash and b dash is 2 plus h plus 1 y, and m dash is again 2, and b dash is also 2. And what is n dash? So n dash is minus 1. So solving for this, you can write h plus 3 by 2 is equal to k plus 3 by minus 1. So let's cross multiply this. So you can see when you cross multiply it, you will get minus h minus 3 and 2k plus 6. And we have seen that h is equal to k. So just substitute it in the second equation. So in place of h, you can write as k. So bringing the k term on the one side. So here you will get 3k, and on this side you will get minus 9. So k you got minus 3. And since k and h is equal, so h will also be equal to minus 3. So what will be our integrating factor? So our integrating factor will be x to the power of minus 3 and y to the power of minus 3. So it will be x to the power of this. So what we do after finding the integrating factor? We will multiply the integrating factor with our parent equation. So what was our parent equation? So let's rewrite our parent equation. So our parent equation was xy square plus 2x square y cube dx plus x square y minus x cube y square dy is equal to 0. So you can see I have rewritten the parent equation. So what I will do, I will multiply this with our integrating factor. So our integrating factor is 1 by x cube y cube. So just we have to divide by x cube y cube. So let's write the terms. So when you will divide the first term with x cube y cube, you will get 1 by x square, and on the y side you will get 1y in the denominator. And the second term, if you see, so here you will get 2 in the numerator, 1x in the denominator, and the y term will get cancelled because y cube and y cube will get cancelled. So this is your first term dx. This, now let's see here. So here one x term will come in denominator because there is x cube in denominator and x square in numerator, and in denominator again y square will come, then minus. Now focus on this term. So here x cube and x cube will get cancelled, and y square and y cube, so you will get one y term in denominator. So this is your dy. So this is your exact differential equation. So we have actually converted our non-exact differential equation into an exact differential equation. So now let's apply our formula of exact differential equation. So we had our formula as m dx plus n terms without x dy plus c equal to 0. So this is our m and this is our n. So let's substitute. So here y constant, m is 1 by x square y plus 2 by x dx. So you have to keep y as constant, plus the second term is n terms without x term. So this term you have to ignore because this is having x. So only term that is without x in n is minus 1 by y. So you have to integrate this plus c equal to 0. So this is your final solution. So let's integrate. So here you have to keep y as constant. So let's bring y outside, and 1 by x square you have to integrate with respect to dx. So it will become x to the power of minus 2 dx integration. Plus if you see the second term, so second term you will have 2 by x integration. So 2 dx by x minus dy by y plus c equal to 0. So here 1 by y, easily you can integrate it, minus 2 plus 1 using the integrating formula, minus 2 plus 1 plus 2. You will know that the integration of dx by x is ln x, and again you will have ln y plus c equal to 0. So now let's rearrange it. So you will get a minus sign because of this, minus 2 plus 1. So 1 minus, and x to the power of minus 2 plus 1 will become x to the power of minus 1, and x will come in denominator. So then the next term is 2 ln x minus ln y plus c equal to 0. So this is your final answer. Okay, so let's solve one more problem. So you can try this problem by yourself. So you can pause the video and try this problem by yourself. Okay, so now let's begin to solve this problem. So what we will do, so we want to first convert this into our general form. So our general form is x to the power of a, y to the power of b, then m times y dx plus n times x dy. Then again same thing, x to the power of a dash, y to the power of b dash, then m dash y dx plus n dash x dy is equal to 0. So here we want one term from dx and one term from dy. So let's take one term from dx and one term from dy. So let's club this two term, and the other two term we will club. So 2y square dx plus 4xy dy. Then the other two terms are 4x square y dx and 3x cube dy is equal to 0. So here you will take common as y. So y you can take as common. So here you will get 2y dx plus 4x dy. Then here you can take common as in these two terms x square. So let's take x square as common. So you will be left with 4y dx plus 3x dy equal to 0. So here you can see that here y to the power is 1. So x to the power will be 0. And here x to the power is 2. So y to the power is 0 because it is 1. So now let's compare and find the values of a, b, m, n, then a dash, b dash, m dash and n dash. So a value is 0, b value is 1, then m value is 2, n value is 4. Now a dash value is again 2, b dash value is 0, then m dash value is 4, n dash value is 3. So now let's solve our equations. So our equations were a plus h plus 1 divided by m, and here b plus k plus 1 divided by n. So value of a is 0, h is as it is plus 1, m is 2, then b is 1, k plus 1, then again n is 4. So h plus 1 by 2, k plus 2 by 4. So do cross multiplication, you will get 4h plus 4 and 2k plus 4. So here you can see that 4 and 4 will get cancelled. You will get 4h is equal to 2k. So 2 will get cancelled with 4. So you will get k is equal to 2h as your first equation. So now let's solve our second equation. So our second equation will be a dash plus h plus 1 divided by m dash is equal to b dash plus k plus 1 divided by n dash. So our value of a dash is 2 and b dash is 0. So 2 plus h plus 1 and b dash is 0. 0 plus k plus 1 and m dash is 4 and n dash is 3. M dash is 4 and n dash is 3. So now solving it, h plus 3 by 4 is equal to k plus 1 by 3. So cross multiplying it, so here you get 3h plus 9 is equal to 4k plus 4. So now so in place of 4k, substituting this, you will get, so if 1k is equal to 2h, so 4k will become 8h. So 3h plus 9, in place of 4k you can write 8h plus 4. So bring this 3k on RHS, so you will get 9 and this 4 on left hand side, minus 4 and 8h minus 3h. So here you can see 5 is equal to 5h. So value of h is 1, and we saw that k is twice of h, so k will be 2. So our integrating factor will become x to the power of h and y to the power of k. So h is 1, so x power 1, y to the power of 2. So this is our integrating factor. So we will multiply our integrating factor with our parent equation. So this non-exact differential equation, we will multiply this with our integrating factor. So let's multiply this. So here let's multiply this with our integrating factor, which is x into y square. So multiplying this, you will get, first term will become 2x y to the power of 4, because here y2 you are having. Then the second term will become 4 x to the power of cube, because x squared and into x will become x cube, and y cube. So this is your first term, plus again multiplying, you will get 4, then x squared and y cube plus 3x 4 and y squared dy is equal to 0. So this is your m term and this is your n term. So this is your exact differential equation now. So we know that we put y is constant, m dx, this is our solution of exact differential equation. Then n terms without x, dy plus c equal to 0. So if you see, there is no terms of n that is independent of x. So this, here also you will get x, here also you will get x. So if you see, this term is 0, so only you have to integrate this m with respect to dx, assuming y is constant. So y is constant, 2x to the power of y4, then 4x cube y cube dx plus c equal to 0. So we have to assume y is constant. So the first you will get 2 to the power y4, and integrating x you will have x squared by 2. Similarly, the second term, if you try to integrate, so here 4y cube, which is a constant, will come outside, and inside you have x cube integration plus c. So here 2 will get cancelled with this 2. y4 x square plus 4y cube. So here it will become x to the power 4 divided by 4, this integration, plus c equal to 0. So this 4 will again get cancelled with this 4. So finally you got y to the power of 4 x to the power of 2 plus y cube x to the power of 4 plus c equal to 0. So this is your final answer. So I hope that you have understand this topic and you have enjoyed this session.